Hey everyone, this is a quick demonstration of the application which I have submitted. The application name is CabSafe. Now, this is a smart cab monitoring system. So let's get started. Now, we are hearing a lot of news about the public safety inside a cab. It's for a woman. It's a very high issue that they are feeling unsafe in this particular area. There are lots of devices which are left around in the cabs, so phones and laptops are getting left behind into the cabs, and they are never found afterwards. Sometimes the cab or auto drivers have to turn into delivery agents, right? So they have to take care of the stuff which they are basically transporting. um, there are lots of cases where driver is not wearing the seat belts. The drivers are not following the rules in a area where it is very important for the passenger. So so the application is basically focusing on these type of problems. So the idea is, let's say the safety is the major concern for passengers and drivers, and we are developing a smart application which are just utilizing IoT and Android things devices to ensure the cabin activity is secure. The application has some key features to detect and prevent potential crimes and accidents. Uh, Here's a potential tech stack for the application, and what we can see here is on the mobile device we are able to fetch the video, and then we can also analyze that particular video nicely. But as we can see, it's not possible for the final application. So what we have developed is a POC where we are basically utilizing our Android mobile, and we are delivering some key insights about the driver. Now, of course, the cameras will be fitted into the car or the auto, and then there will be some kind of a hardware which should be in place, and then we will assume that this particular thing is running. So the first solution here is crime detection. Now, what we can do is we can have a good view about the inside cab, and then we can see, we can even detect on time to time whether this particular camera is having some crime detection alerts. Now, what we are not doing is we are not sending this data outside into a cloud area, because this is an activity detection algorithm which can actually run on the device in the processor of the mobile. So definitely it can run into let's say a small Raspberry Pi or something like another hardware. So inside the mobile only we are basically doing the crime detection. The second can be, let's say, either the driver has some fatigue, right? So there can be necessary steps for utilizing some facial expressions for that. There can be some smoke or heat stove detection, because sometimes which happens is, maybe in India it really happens that the temperature rises up to 40 degrees, right? And there can be, let's say, a heat warning for the cab driver, so that we can give him that particular alert. uh, Now, in many cases, we have seen that even children are, placed inside, and they are basically left outside into the vehicle. So it can help even the normal user, but it is a potential, child detection algorithm. So the cost of it can be thought of as, let's say, a one-time cost for setting up the whole solution, right? And then some cloud, cost we can incur for running this particular dashboard. Now it has a very good impact in a sense that always there is a camera for for the evidences. There the security of the passenger as well as the cab driver is maintained, so both of them are secure. So the customer is basically utilizing this security solution is according to that particular need. And then this is a privacy first device, right? So all the data which is getting analyzed is on the device, so nothing gets outside into cloud. So it's better for the privacy of everyone. Now let's check a quick demo of the application. So as we can see, It's running in my Android phone, and currently it is telling the condition of the driver, a potential driver, and then even the direction in every direction, x or right. So in the horizontal position, I can say that I'm looking into straight into the mobile, maybe on the left if I move, on the right if I move, on, or I can just do a top and bottom area. Now, what if the driver is not awake? So let me present that scenario as well. Yeah. So as you can see, the condition changes very fast, right? So it's running on the device, and the display is not needed. So it's not needed in the final application. So it's just a UI which I have provided. But let's say this display will not be every time visible. It will just collect the data in the background, and then the data will be stored into a log file. This is one application. There is a second application as well, where we can see that we have made a audio recognizer. So as you can see, what I'm speaking right now is getting detected. So the speech is getting detected here. Now there is a model which we have used for this particular thing, and the model is essentially this particular data set, where we can see that we have trained it on the audio set. So as you can see, it is using, let's say, the speech data. There is some shouting in case there is some screaming also, or some whispering or laughter. So all the different use cases are covered are covered here. And then as you can see, if I play any if I, let's say, want to demonstrate some particular instance. So all these classifications will be stored into a log file, as I said earlier. And what it will do is, it will have those tagged data sets in the background, right? And then we can monitor it separately for our cab driver. So let me demonstrate a sample audio. So as you can see, the classifications came instantly, right? The model is very lightweight, and both of the models are using TensorFlow Lite in the background, right? Which means that the application will consume a low amount of memory, and performance-wise, is very fast. The data set which it has trained on are some of the very well-known classes. So as you can see, lots of different fields can be used up for our cap safety. One thing which I wanted to point out was, so all this data, right, is basically trained inside a particular let's say device. Now all the inferencing is done on the device, and as you can see, all the background noises, or let's say the human sounds, will be captured from the mobile phone, right? And this particular app will be running in the background, where we can basically say that for the inside the cab, all the natural things are happening regularly, but it is not really affecting the normal use case of the cab. uh, the final thing is, let's say, the solution is trained using TensorFlow, right? And this same stuff, right, can be used inside a hardware which is basically a Raspberry Pi, or a different particular amount of model, which can be distilled down into, quantized into a different format. So what we can think of it is nothing but, let's say, a Android device. It can be a mobile phone right now, because that is what we are presenting, but let's say it can be a hardware of a Raspberry Pi as well. So these are two applications which I have submitted for so this was the product which we are basically having. So thank you.